Hey guys, hope everyone there is doing well. Um, it's now the second day I've been gone, so I hope you're behaving for Miss Tierney. Um, Hopefully, I'm in Spain, maybe on a cruise ship, maybe not, depending how that goes. We might just stay in Spain for the week too. So I'll be thinking about you, but hopefully, you'll be able to follow these lessons and do everything that's expected of you. And you can obviously ask Miss Tierney or any of my wonderful paras for help. So the lesson we're going to do today, you have your note sheet in front of you, is going to be on probability. So we have to know the probability section of the MCAs is actually quite easy. But we still have to know certain words so we can get all these answers right. So just first of all, 4 words that we need to know before we do probability is the first word is probability. And probability, you would just want to write, it is the chances that something can happen. And if you think about that, that would range. So you would think, well, chances of something never happening, so never would be a 0. That would never, ever happen. And then the opposite of never is always. Something always will happen. That's called also a certain event. That probability is 1. And a lot of kids don't understand why that's 1. Typically, probability is in fractions. And if you think of fractions like 6 out of 6, 5 out of 5, 4 out of 4, 3 out of 3, you know how those always reduce to 1. That's why when you say anything that always happens is equal to 1, because your fraction is 5 out of 5, 7 out of 7, which is the same as 1. Obviously, most probabilities are between these two places, between 0 and 1. So usually they are fractions, or we think about them as fractions. Half the time this will happen, 3 out of 4 times this will happen. That obviously is a fraction that ranges between these two spots. Okay, second word you got to know is what an outcome is. So an outcome literally is just what can happen. What can happen. So if I talk about what are the outcomes of flipping a coin, you would say, hopefully, heads and tails. That's what can happen when you flip a coin. So those are the outcomes. If I say, what are the outcomes of rolling a die? I'm assuming you guys would all say you could get a 1, 2, 3, 4, 5, or 6 on a normal die, and that would be what the outcomes are. So that's just what the word outcome means, what could happen. The next is theoretical probability. And in the word theoretical probability, you can kind of see what it would mean just by looking at what I'm underlining here. In theory, it's what we think should happen. So we'll put what we think should happen. This is the mathematical part of probability. So this is all like our predictions. This is when you say, I think we should get a heads on a coin half the time. We should get it half the time. But we know that if we only flipped a coin twice, you could easily get heads and heads. And that's not heads half the time. The reason that doesn't happen is because your experiment that you're doing isn't enough. Where if you flip the coin 100 times, probably about half the time we would get heads. It would kind of average out. So it's what we think should happen. We use a formula for that, which we'll talk about in a little bit. And the last thing is experimental probability. And you can kind of see what that means just by that root word too. So experimental probability is what actually happened. What happened in the experiment. Okay. So it's what happened in the experiment. These kind of questions, these kind of questions will be, you won't have to really do the math, you just have to interpret it. What I mean by that is they're going to give you a chart and they're going to say, hey, this person flipped a coin and this is what happened. And then they'll say, what's the experimental probability of getting a tails? That means don't say half. You actually look at the results and report how many were tails. So experiment, we don't think of what should happen, we just actually report what did happen. Another word for this, let's put this on there, is relative frequency. And I never know which one they're going to use. So it's going to be the same thing. They might say, what's the relative frequency of getting a tails? Basically, they're going to give you a chart. You count up how often they have tails. If they say, what's the experimental probability that the next car is red in the parking lot? They would obviously have a chart, and they would have all the different colors of cars, and you would count up how many are red over total. So we'll practice with that one a little bit. Okay, so now we're going to see if you can just answer some questions. If I just asked you, what are the outcomes of rolling a die? What would you say? Raise your hand. Good. Hopefully you said the outcomes would be a 1, 2, 3, 4, 5, or 6, because that's what's going to happen when you get a die. How about flipping a coin? Raise your hand. Hopefully you said heads or tails. And what's the outcomes of getting a certain colored car in a parking lot? Raise your hand. Good. If you said red, black, white, silver, blue, basically you could say any color that cars are made. So there could be more, but basically I just want you to get the use of, if I just say what outcomes are possible, you're just going to say what can you get. If I said you have some marbles in a bag and these are the colors, and I would say what are the outcomes, you would just basically list the colors. All right, on this slide, basically it's looking at theoretical probability. Again, in theory, what should happen. And there is a mathematical formula for that. First of all, I need you to get used to seeing this P in parentheses. Excuse me, just a second. So when you look at this P right here, that's just stands for probability. And so when you're looking over here, it's saying P in parentheses red. That's just basically saying probability that you'll get a red on that spinner. And so if you look at this formula, this is what it tells you to do. The bottom number is the number of possible outcomes. So if I spin this spinner right here, you can see there are 4 different colors, and that's why the probability, the bottom number is a 4. So total things can happen is always your bottom number. The top basically answers your question. So the question is, how many are red? So you can see up on this spinner, there's only 1 red. So the chance of getting a red is 1 out of 4. On this slide, they can also ask you probabilities that something won't happen. So if you look down here, it says probability of not getting a red. So our bottom number is going to be basically the same, because the bottom number is how many total things can happen on that spinner. And there are 4, so the bottom number is a 4. And then how many are not red? So the top number answers the question. If you look at how many are not red, this isn't red, this one isn't red, and that one's not red. So basically our probability of not red would be 3/4 of the time. Okay, now we're going to switch to just looking at dice. And the question at the top says, what's the probability of giving an even? So over here it says probability of getting an even number. And so when you raise your hand, tell me what you think that is. Hopefully you said the bottom number has to be a 6, because there are 6 different numbers on the dice. And the top number answers your question. How many are even? The number 2, the number 4, and the number 6 are even. So that would be 3 out of 6. And we know that I like all my fractions reduced. So even though it is 3 out of 6, we want to reduce it to 1/2. So half the time you get an even, half the time you get an odd. And then that basically answers our question on the bottom. What's the probability of getting an odd number? So if half the time you get an even, that would make sense, hopefully, to you guys, that half the time you would get an odd. There are 6 numbers on the dice. 3 of the numbers are odd, 1, 3, and 5, which would reduce to half. Okay, on this slide, let's see if you guys can answer these questions. So the top question, it's saying, what's the probability of not rolling a 2 or 3? So can you raise your hand and tell me what you think that is? Okay. So hopefully you said there are 6 numbers on the dice, so the bottom number is a 6. And then basically we have to answer the question, how many are not a 2 or a 3? Well, the numbers 1, 4, 5, and 6 are not 2 and 3. So that's 4 numbers right there. And when, of course, when we see even numbers, you guys took a pledge never to leave that. So you know to divide by 2, which would say 2/3 of the time. You won't get a 2 or a 3. This one right here, what's the probability of not rolling a 4, 5, or 6? Raise your hand if you know that. Okay, hopefully you guys said bottom number still a 6 because there's 6 numbers on the dice. Top number answers the question. Not a 4, 5, or 6. So the only numbers that are not 4, 5, or 6 would be a 1, 2, or 3, which is 3 of the numbers. So 3 out of 6, and we all know that reduces to half. All right, let's try this one. So we have a pail, contains 8 red marbles, 5 blue marbles, 6 green marbles, and 3 yellow marbles. If a single marble is chosen from the pail, what's the probability to be red, blue, green, and yellow? So we have 4 to do right there. So raise your hand if you can figure out how many are red. Okay, it's kind of hard to count those the way they're in that bucket. So it's actually easier to look at your question up here and say, underline like your numbers. So there's 8 red, there's 5 blue, there's 6 green, and 3 yellow. And if you add all of them up, that bottom number is 22. So we know our total outcomes is there's 22 different marbles to pick from. Top answers my question. You can come over here and count the red if you want, or you can just look up here. There are 8 red. So we should have said 8 out of 22. And we all know we can divide that by 2 because it's even. So you would say 4 out of 11. The next one is what's the probability that it'll be blue? Raise your hand. Hopefully you guys all said 22 is the bottom number. And the top answers my question, and I can see right there, 5 are blue. So 5 out of 22. And then we have green. Raise your hand if you know the green. Bottom number is still 22 marbles, and there are 6 green. They're still even, so we know we have to cut them in half or divide by 2, which would end up with 3 11ths. And finally, yellow. Raise your hand. The bottom number is 22, and hopefully you said there are 3 yellow marbles. You can see it, count it in the bin, or you can see it in the problem. Okay, last question. What color are you most likely to get if you pick a single marble out of the pail? And what color are you least likely to get? Well, if you just look, obviously the one you're most likely to get would be what you have most of. So if I was going to bet, I would bet on red because we have the most red. So most likely would be red. Doesn't mean there's a guarantee, but it's most likely to be red. And least likely is what there's not many of. And there's the least probability, if you look at the first probability is when the 22s are on the bottom, the smallest number was the yellow, 3 out of 22. So yellow, if you were gonna be a betting person or playing a game, I probably wouldn't pick yellow to be picked. All right, now you guys are gonna play a game. So this game is a race, and you guys are either gonna bet on the green car or the red car. Miss Tierney is gonna roll a dice, and if the dice lands on a 1 or 2, the green car will go forward 1 space. So Miss Tierney will put an X right there. And if she rolls a dice and it lands on a 3, 4, 5, or 6, the red car will win. So why don't you decide right now, which one do you think is going to get way over here the fastest? The green car is going to move every time she rolls a 1 or a 2, and the red car is going to move if she rolls a 3, 4, 5, or 6. Just real quickly, decide, raise your hands which one you think we should pick. Okay, I'm assuming most of you said let's go with the red car because you think the red car is going to win. So to make this game a little more interesting, I'm gonna give everyone who wins a piece of candy. So Mrs. Tierney has my candy bin, and if you pick the right car, you're gonna get a piece of candy. However, if you pick the green car and it wins, you get 2 pieces of candy. So now decide, do you want the red car or the green car? If the red one wins, you get a piece of candy, 1 piece. But if you pick green and it wins, you're going to pick 2 candies. So how I want you to play this game is I want Miss Tierney have the people that want the green car to stand up and have the people that want the red car to sit down. And then Mrs. Tierney is going to go ahead and play that game with you and give the candy out to whoever wins. Good luck. So most of you know that, of course, the race wasn't fair. More than likely, the red car was going to win. But I bet some of you still picked the green car. Even though you know you probably weren't going to win. Why do people do that? Well, most often it is because greed takes care of them, right? It's kind of like, why do people buy lottery tickets? Do people really think they're going to win the lottery? They probably know not, but the prize is so big that they're willing to take $1 or $2 to play the game. So they're betting on something that probably won't win, and that's what the people that bet on the green car winning. I think mathematically you knew that the red car should win, and I'm assuming the red card has won. I've never seen the green car win. I've seen it get close though, so hopefully the red car won and it worked out mathematically. Okay, so let's see if you can answer these questions. What's the probability of choosing a king from a standard deck of cards? Raise your hand. All right, so a lot of kids will tell me when they get questions on card, I don't play cards. That's fine if you don't play cards, but you're still expected to know about decks of cards. So either way, whether you play cards or don't, we have to memorize, what does a deck look like? How are they? So in a deck of cards, there's 52 cards. So when they ask you about a card deck, your bottom number is always going to be 52. The top number answers your question. Basically, how many kings? So there are 4 of every single color. There's a king of hearts, a king of diamonds, a king of clubs, and a king of spades. So there's always 2 red hearts and 2 black hearts. Sorry, I said that wrong. 2 red cards and 2 black cards. Red are hearts and diamonds, black, clubs and spades. So when you say how many are kings, well, there's 4 of them. Now, we know that we can't leave that because it's even. So we can reduce that. You could just plug that in your calculator. Type in 4, fraction line 52, and the answer becomes 1/13. Second question, what's the probability of choosing a queen or a 10 from a standard deck of cards? Raise your hand if you know that one. Okay, I'm assuming you guys put 52 as the bottom. And then, of course, if there's 4 kings, there must be 4 queens. If there's 4 of every card, we also have 4 tens. So it's saying queen or 10. So you can get either one. So 4 queens and 4 tens would be 8 different cards. 4 being the queens and 4 being the tens. You can see those are even numbers. So we are going to reduce that. You can plug that in your calculator and it will reduce to 2/13. Next one, what's the probability of choosing a purple marble from a jar containing 3 purple, 2 green, and 8 orange marbles? Raise your hand if you know that one. All right, so the first thing you should have done is figure out how many are there in all. You have 3, 2, and 8, and that adds up to 13. And then the top answers your question. How many chances of getting a purple? Well, you can see there's 3 of them. So your probability is just 3 out of 13. Last one, if the letters in probability were placed in a hat, what would the probability of choosing a B in a single draw? Go ahead and raise your hand. So hopefully what you did is you counted all these letters because they said you put them all in a bag, and I believe there are 11. 3, 6, 9, 10, 11. So your bottom number is going to be an 11. And then the top number answers your question. How many are B's? Well, there's 2 of them. So you can see this theoretical probability is pretty easy stuff. Okay, now we're going to actually do an experiment, and we're going to see how experimental probability is different than theoretical probability. We're going to look at the chances of rolling a 5. Okay, so in theory, We know we should roll a 5 how many times? Raise your hand. Hopefully you guys said you should roll a 5 1 out of 6 times. Why? There's 6 numbers on a dice and there's only one of them as a 5. So it should happen 1 out of 6. That doesn't mean we're guaranteed to happen 1 out of 6. So what I want Mrs. Tierney to do is give every table one dice. So that each, you can be partners in this. So every table gets one dice. And I want you to actually roll the dice 6 times. And I want you to record your numbers. So like you roll it and you roll 1, write 1 down. You roll it again, you roll the 4, write a 4 down. Okay, and I want you to write your 6 different rolls. So I want you to take a minute and do that right now. Okay, so hopefully you have your numbers down. So if you look just at one group, so Mrs. Tierney is going to go ahead and call on one group. Or actually it'd be better to do this. Raise your hand if you only got a 5 1 out of 6 rolls. So was there anyone that matched that probability? So you can see probably, if I had to guess, most groups probably weren't exactly 1 out of 6. Why? Well, you only rolled it 6 times. But what I want you to do now with Miss Tierney is you're going to actually add these up. So we're looking at rolling a 5. So we're going to go ahead and take however many groups there are in the room. So if there's 10 groups in the room and each of you rolled it 6 times, your bottom number is going to be 60, right? If there's 12 groups in the room and everybody rolled it 6 times, your bottom number is 72. I think Miss Tierney's getting this math. I think you guys also get this math. So basically, you're going to take however many tables did this and times that by 6 because that's how many rolls you actually did. And the next thing now you need to count is Miss Tierney will go ahead and ask every group exactly how many 5s did you roll. So you're going to go ahead and count how many 5s did the entire room roll. That's going to be your top number. Go ahead and calculate that now. Okay, my guess is it's still not exactly 1 out of 6, but is it close? How do you figure out if it's close? So it's pretty easy to do that, to tell. It's hard to compare fractions, but it's actually pretty easy to change those to decimals. So what I want you to do is I want you to change 1 over 6 to a decimal. Hopefully you all have calculators in front of you. Basically, you guys all know what to do. 1 divided by 6 is what? All right, so 1 divided by 6 is 0.16 repeating. And now what I want you to do is take your class number. So whatever this number is, it depends on how many kids and tables you have. Basically take how many 5s you have and divide that by your bottom number to find out your decimal. Now look and see, are your decimals close? I think you would agree, guys, the more you do this experiment, the more tables we have in the room, the closer we're going to be to that number. If we only had 3 tables do this number wouldn't be as close to 0.16 repeating, but the more tables that we have, the closer you get to the real probability. One more thing they might ask you on the MCAs is they'll say, oh, this is what happened. She flipped a coin this many times. They'll give you a result, and they'll say, how does the experimental probability compare to the theoretical? So we know the theoretical probability of a coin getting heads would be half. And then your experimental is just like how often it did happen. And it might, you might have a chart that says it happened 8 out of 10 times. Well, obviously the experimental 8 out of 10 is way more than half. So you would write that. You would be like, experimental is greater than theoretical. But then they would ask you why. Like, why aren't they the same? So your answer on that is why don't the probabilities match is because anything can happen in an experiment. Theoretical is what should happen if we did it many times, but experiment is what actually did happen. So that's going to be your kind of rationale on that if they ask you why don't they match, because you're not guaranteed a match on theoretical and experimental probability. Okay, last type of questions here are, these are very much like you see on an MCA. It says a class contains 10 boys and 15 girls. Teacher calls in a student at random. If the teacher asks 90 questions, How many times do you expect a girl to be called on? So the first thing you're going to want to do is look at what's the chances of a girl being called on. So we want to figure out how many people are in this room. Well, we have 10 boys and 15 girls. So the chance of getting a girl, so if you add those up, that's 25 people. So there's 25 kids in this room, and we want to say, oh, there's chances of being a girl picked would be 15 out of 25. So that's your step one. Figure out how often it should happen. But step two on this question is, that's how often 15 out of 25 are going to be girls when you call on them. But now you're going to not ask 25 questions, because if you ask 25 questions, 15 times you should be calling a girl. You're going to ask 90. So really what we're going to do is these lovely proportions that we just got done doing, and we are going to say, well, 15 are girls. How many are girls? If we pick 90 times. This is if we pick 25 times, it'd be 15 out of 25. Now we're going to pick how many girls out of 90. And basically, I'm hoping we all know how to do that. You're going to multiply across and divide, and you're going to get your answer, which is what? Raise your hand. Okay, here's our last question. Each night at dinner table is randomly set with 5 red forks, 3 blue forks, and 7 green forks. If you eat at this table for 45 nights, how many times would you expect to eat with a blue fork? So first, you just have to think about one night. Don't think about 45 nights. Think about if you sat down tonight, what's the chances of me getting a blue fork? Well, it starts with figuring out how the heck many forks we got. We got 5 red, we got 3 blue, and we got 7 green. So if you add that up, we have 15 forks. So there are 15 total forks to pick from. That would be your outcomes. And then the chances of being blue is 3. So it would happen 3 out of 15 times. But now they're going to ask 45 nights, not just 15 nights. If it was 15 nights, it'd be 3 out of 15. But they're saying, nope, let's change that to 45. So here comes the wonderful proportion. So 3 out of 15 is the same as what? Out of 45. Raise your hand if you know that answer. And hopefully you answered 9. All right, so now here's your homework. So go ahead and get started. And if you have any questions, ask the teachers.